Hello friends, welcome to Systematic Physics. Here we will be guiding you for content of physics for boards, NEET and JEE. Oscillations, Competitive Exam Corner, Level 1, Set 2. Energy in simple harmonic motion. Kinetic energy is equal to half mv square. So you know what is v equal to? A omega sine omega t plus 5. So it becomes half m a square omega square omega t plus 5. Now sine square theta can be written as 1 minus cos square theta. So x is equal to a cos omega t plus 5 for the displacement. K is equal to 1 upon 2 m omega square a square 1 minus cos square omega t plus 5. Now k is equal to half m omega square a square minus x square. So m omega square is replaced by k. So what I get is kinetic energy is equal to half k a square minus x square. From this expression we can see that the kinetic energy is maximum at the center when x is equal to 0 and at extreme it is minimum. Potential energy. Expression for potential energy is equal to half m omega square x square, replace that m omega square by k. So you got an expression for potential energy equal to half kx square. Now in this case if you put x is equal to 0, which is mean position, the potential energy turns out to be 0. And if you write x is equal to plus or minus a, we get a maximum potential energy. Total energy. Kinetic energy plus potential energy, that is equal to half m omega square a square. So total energy E is equal to half m omega square a square. So where m omega square is equal to k. Thus with the total energy of SHM is independent of time or displacement. The variation of total energy E, potential energy U and kinetic energy k with displacement x. Differential equation of linear SHM. We know d2x by dt square plus omega square x is equal to 0, where d2x by dt square is an acceleration and omega square is equal to k by m. So omega is equal to square root of k by m. Composition of SHM, we have two SHMs, x1 is equal to a1 sine omega t and x2 is equal to a2 sine omega t plus 5. If you write x1 plus x2, then x is equal to a sine omega t plus 5. Resultant amplitude A is equal to a1 square plus a2 square plus 2a1 a2 cos theta, and tan beta, that is phase difference, is equal to a2 sine phi upon a1 plus a2 cos 5. Angular simple harmonic motion. Theta is the angular displacement at any instant, and resultant torque acting on the body in the angular SHM would be tau is equal to minus k into theta. If the moment of inertia is I, the angular acceleration alpha is equal to tau by I, which is equal to k by I into theta. Now k minus k by I into theta can be written as omega square theta, because that is an expression for angular acceleration. So k by I is equal to omega square. So omega is equal to square root of k by I. Now I know theta is equal to theta 0 sine omega t plus delta, where theta 0 is the maximum angular displacement. The angular velocity at time t is d theta by dt, that is theta 0 omega cos of omega t plus delta. The time period of oscillation would be equal to 2 pi square root of I by k, where omega is equal to square root of k by I is the angular frequency. Problems based on energy in SHM. The resultant of two rectangular single harmonic motion of the same frequency and unequal amplitudes but differing in phase by pi by 2 is option A simple harmonic, option B is circular, option C is elliptical, option D is parabolic. Y1 is equal to A1 sine omega t, which gives me sine omega t is equal to Y1 by A1. Now I know y2 is equal to a2 sine omega t plus 5 by 2, which becomes a2 cos omega t, because sine omega t plus 5 by 2 is cos omega t. So which gives me cos omega t is equal to y2 by a2. Square both the sides, you add it. So you get y1 square upon a1 square plus y2 square upon a2 square is equal to 1, which is equation of ellipse. So the answer C, option C is correct answer. For a linear harmonic oscillator, its potential energy, kinetic energy and total energy EP, EK and ET respectively. Its maximum acceleration is given by A square root of 2 EP by m, B square root of 2 EK by m, C square root of 2 ET by ma, and D 2 ET upon ma. In SHM, maximum acceleration is omega square into a. Total energy is equal to half m omega square a square. If I adjust these terms, I get omega square a is equal to 2 ET upon ma. That is the option D. Problem number 11. A particle is executing SHM with an amplitude A. When the P of a particle is 1/4 of its maximum value during the oscillation, its displacement from the equilibrium position will be option A by 4, option B A by 3, option C A by 2, option D 2A by 3. Potential energy is equal to half m omega square y square, which is equal to 1/4 of the total energy. The formula for the total energy is half m omega square a square. Cancel out all the terms. You get y is equal to plus minus a by 2. That is option C. Problem number 12. Force constant of a weightless spring is 16 Newton per meter. A body of mass 1 kg suspended from it is pulled down through 5 cm from its mean position and then release. The maximum kinetic energy of the body will become. Option A is 2 into 10 raised to minus 2 joules. Option B is 4 into 10 raised to minus 2 joules. Option C is 8 into 10 raised to minus 2 joules. And option D is 16 into 10 raised to minus 2 joules. You know, omega is equal to square root of k by m. K is known to you 16, m is 1, so it becomes 4 radians per second. Now k max is equal to half m omega square a square. Put all the values of k, omega and a. You get k max is equal to 2 into 10 raised to minus 2 joules. The option A is the correct answer. Problem number 13. The total energy of the body executing SHM is E. Then the kinetic energy when the displacement is half of the amplitude is. Option A is E by 2, option B is E by 4, option C is 3E by 4, option D is root 3E by 4. Total energy in SHM is E half m omega square a square, where a is the amplitude. The kinetic energy K is equal to half m omega square bracket a square minus y square. You open the bracket, so you get E minus half omega square y square. Now when y is equal to a by 2, you put the value there. So you get it as 3e by 4. Problem number 14. SHM is executed by the particle of mass m. The displacement of the particle is 1 upon root 2 times the amplitude. What fraction of the total energy is the kinetic energy at this displacement? Option A is root 3 by 2. Option B is 1 by root 2. Option C is 3 by 4. Option D is 1 by 2. For a body executing SHM, the total energy ET is given by half m omega square a square. EK is equal to half m omega square a square minus y square. Now put y is equal to a by root 2. When you put that value, you get EK upon ET is equal to 1 by 2.
We have tried giving you the subject knowledge in very systematic manner. Please like and share the video with your friends and subscribe to stay connected with systematic physics.
Thank you.